In this video, I'm going to talk about a correction I have to my surface integrals video I had done earlier. And this error I had was pointed out to me by William in the comment section of the surface integrals video. And what he asked is, my final answer was negative, which I said that represented an inward flow. And he asked, well, how can that happen since we have a radial vector field which points outwards everywhere, which was a really good question. So normally for a small computation error or something transcription error, I wouldn't do an entire correction video. But because this was a conceptual problem, I have this correction video here. So the first thing I noticed is I actually transcribed this from when I was doing the solution, I had dropped a cosine phi term here. So this normal calculation for the last coordinate should be minus sine phi cosine phi, and then it's also sine squared theta plus cosine squared theta, but this goes to 1. So the normal that I should calculate here should have been negative cosine theta sine squared phi, sine theta sine squared phi, sine phi cosine phi. That was the first error. That error wouldn't have warranted a whole nother video. I would have just made a comment to say, oh, I have this correction here. However, it's the fact that I chose this, or I took this normal as it was, the negative normal, and I used it in my surface integral. If you recall, in that video, I talked about surfaces having orientation. So if you think like a flat tabletop as a surface, it has a positive orientation pointing upwards towards the ceiling and a negative orientation pointing downwards towards the floor. So every surface has a positive and negative normal, and in our surface integral, we need to choose the positive normal. Also, we talked about for a closed surface that the positive orientation is pointing away outwards, outside of the closed surface, whereas the negative orientation is inwards towards the center of the closed surface. So here we have the negative orientation, but again, for the surface integral, we need to choose the positive orientation. So the normal that I should have used was cosine theta sine squared phi, sine theta sine squared phi, and sine phi cosine phi. And again, the positive, not the negative. Here I rewrote all the notes, including my positively oriented normal, and I plugged this in to my surface integral. Here's my positively oriented normal, as well as my radial vector field composed with my parameterization of my sphere. I do my dot product. Oh, one other thing I did, just to simplify the integral later, and I should have done this before, but I didn't think of it until I was reworking this problem. I pulled out a sine phi, a factor of sine phi from my normal, so that I get sine phi times cosine theta sine phi, sine theta sine phi, and then cosine phi. Then I dot this with my r, my radial vector field, and I keep my sine phi out, and the dot product of these two vectors simplifies to 1, so that totally simplifies my integral to just the integral of sine phi. I do the integral and I get a positive 4 pi, which means the flux is positive, which means we have an outward flow, which is now consistent with my radial vector field that points outwards. I would like to repeat my thank you to William for pointing out that conceptual error. I would like to apologize for that error and offer you this correction video. Thank you for watching.